Hi guys, welcome to my videos. This video is for who interested in food industry and food technology. My name is V by the way. Let's start the video.
The topic today is about the plant that's very popular with us. Look at the picture. Have you recognized yet? Yes, that is sương sao in Vietnamese, and in English we call it Asian grass jelly because its texture chewy like jelly and is common in Asia. Combine these ingredients, we can create the pectin. So, the food topic I will present in this video is extract pectin from Asian grass jelly, or have a scientific name is Mesona kinesis band. So why I choose this research to present? Now I will answer that question. What you see on the left hand side is the grass jelly have been dried. After extracting process, we will collect the pectin. So this study aims to determine the effective condition around extracting pectin with high yield as a database for research and development of technology to produce pectin from plants. In this study, I will divide into three main parts. The first is introduction. In this part, I will introduce a little bit about pectin and the Mesona canis band. The second is materials and methods. I will show you some material used in this research and some technique method. At the final, I will show you the result, and after that we will discuss the result. Continue with the next slide. Started with pectin. Pectin is a gel-forming compound derived from higher plants and have a lot of in apple pulp and such as peels. It's also an effective thickener, emulsifier, and a stabilizer. So it's be used wide application in food technology. Pectin have been found a lot in the stem and the leaves of the plant of Mesona canis band. So Mesona canis band is a hibiscus. It's short and resin jelly in water. Used as a soft drink. Grow well on grassy and sandy soil. It's also used as a pharmacology when you're sick, like cough, fever, and so on. Move to the part 2, materials and methods. In material, we have the main ingredient that is mesona and some chemical substances such as acid citric, acid sodium hydroxide, and so on. In the method, we have calcium pectate method used to determine pectin content, and raw material moisture is determined according to TCVN. The characteristics of dew point pectin were determined by MI microcell, AUA anhydrogalactonic acid, and ester DE. Now, let's find out the way we extract pectin from grass jelly by the flow chart below. First, we soak 5 grams of dry grass jelly powder for 1 hour with 5% citric acid solution at 85 Celsius degrees, then centrifugal to separate the extract and cool. Using alcohol 96 degrees to precipitate pectin in the extract, filter and collect the crude pectin with dry filter paper of non-constant mass. Finally, the crude pectin precipitate will wash several times with cold alcohol and dry at 50 degrees to constant weight. Then the crude pectin precipitate after drying was allowed to cool and determined by analytical balance. Based on the calcium pectate method, the pectin content in the raw material determined as mass of crude pectin after extraction, divide dry weight of sample, multiply 100. We all done the preparation step, and now we will discuss the result in the final part. In this part, I continue separate into two small parts. The first one is assessment of raw material quality, and the second is factor affecting pectin extraction efficiency. Move to the next slide to discuss the first one. In the table 1 show that the moisture content of fresh mesona in Thieng is very high, 86.26%, while in Thieng and Đồng Tháp, dry mesona are just 13.61% and 11.41% respectively. Pectin content obtained from Đồng Tháp was only 8.7% compared to 9.3% in Thieng dry. Therefore, Thieng dry was selected as the main raw material in the next study. Part 2. Some factor affecting pectin extraction efficiency, that is solvent concentration of citric acid solution, raw material solvent ratio, time, temperature, and the preliminary assessment of the obtained raw pectin quality. Now let's figure out the detail of these factors. In the first column chart, 3 types of solvent were investigated for extracting pectin: is water, hydroxide, and 5% citric acid solution. The results show that treating the raw material with 5% citric acid solution, the recovery efficiency was 7.2%, 5.14 times higher than using water and 2.7 times higher than hydroxide solution. On the other hand, citric acid is a safe organic solvent, non-toxic if left in the product. Therefore, citric acid was selected as a solvent for extracting pectin from mesona for further investigation. In the figure 2, the results show that when the citric acid concentration increased from 3 to 12%, the extraction efficiency continuously increased from 4.34 to 18.22%. However, when the acid concentration increased from 12% to 15%, the pectin extraction efficiency decreased to 16%. It is possible that the increase in acid concentration caused the bond between the polysaccharide chain in the cell wall to be broken, allowing the pectin to be released more easily. But when the concentration of citric acid increased, the pH decreased, which can cause the bond in the polygallutonic acid chain to be strongly cleaved. Part of the pectin is decomposed and leads to the decrease in pectin extraction efficiency. Continue with this factor. 3 figures here show the result from raw material solvent ratio, time, and temperature. The result in figure 3 show that the extraction efficiency increased from 7.8 to 15.66% when the material solvent ratio changed from 1/10 to 1/25. However, the extraction efficiency at the ratio 1/20 and 1/25 was not statistically significant. Author Xin Wang, when studying the extraction of pectin from apple pulp, also found the same rule. In order to ensure high pectin extraction efficiency and safe solvent, the ratio of raw material solvent was shown to be 1/20 gram for further study. Next to the time figures, extraction efficiency increased from 8.6 to 20.66% when the processing time increased from 30 to 90 minutes. The highest extraction efficiency was 20.66% after 90 minutes of processing, but continuing to increase the processing time to 120 and 150 minutes. The performance decreased by 1.62 and 1.71 times respectively compared to 90 minutes. Continuing to increase the processing time, pectin can be decomposed by high temperature and long time, so the extraction efficiency decreased. The temperature results show that the effect of processing temperature on extraction efficiency is similar to the effect of time. Accordingly, the extraction efficiency reached the highest at 85 degrees and tend to decrease as the temperature continued to increase. This is explained by the fact that when the temperature is too high, the pectin will be denatured, thereby reducing the extraction efficiency. The next sector is preliminary assessment of the obtained raw pectin quality. First, I will compare in pectin content between raw pectin and standard pectin. Raw pectin have a dark brown color, malleable and hard to crush, while in standard pectin is white and fine powder. Analytical research showed that in the obtained raw product, only 6.99 per pectins were obtained. Move to the second. Analysis of functional groups in raw pectin preparation. Here are two figures. In the left is ER spectra of standard pectin, and in the right ER raw pectin. The data will show in the result by table. The OH carbonyl CO, carboxyl ester COO groups in the two pectin samples were observed at similar wave number and similar to the research result of Chitra Singtong in 2005. When analyzing the property, pectin ejects from the leaf of chromanoid. Thus, it can be confirmed that the sample extracted from Mesonaria canispan powder is pectin. Now, it's a time for sum up all things we have discussed. Extraction efficiency of pectin from Mesonaria canispan reached the highest value of 9.3% when extracting with citric acid, 12% with the ratio of raw material solvent of 1 per 20 gram per milliliter at 85 Celsius degrees for 90 minutes. Crude pectin obtained from Mesonaria canispan belong to low methylated pectin group MI 3.162%, DE index 41.803%, and molecular weight 7,042.25 units.
And if you want more details, here are some references for you to check out. And that is the end of the topic. Thank you for your listening, and if you like this video, please like and subscribe my channel. Thank you so much.